After the bell rings, Carly Hannah, please come to the office. Carly Hannah.
Where you wear that every single morning? I do.
Carly Hannah, please come to the office. Carly Hannah.
Welcome back. Alright, let's talk about a few things today. Okay, I know we had homework on Friday, so I want to make sure that we can discuss that today. That was 1 through 7, 9 through 20. I do want to talk about a couple of those problems so that you know kind of what you're doing on those. And today we got to talk about some field properties. Those are new properties that I hinted at, last Tuesday, but we didn't really see them, Thursday or Friday because they weren't required for the homework. They're going to be required for future homework. So that's what we're going to be talking about. Okay? So let's do a quick review of those properties of equality, and I want to talk about how the homework works, like what you were supposed to do. Okay? All right. So let's put the properties up here. All right. Here we go. Here's the properties we talked about on Friday and hopefully Thursday if you were here. Rounded it. Okay. So, the properties that we're talking about today, that we talked about Friday, reflexive property. That's where you set something equal to itself. Okay, it's an exact copy. Now, what we talked about for us right now, the only thing that we ever do is like, if we had an algebraic expression, and then you had it set exactly equal to itself, and then you want to work with one side to simplify it. So you're just like kind of showing the work off to the side, but you started with the original problem. It's not helpful for right now. This is a big one for like geometry proofs. When we get it like actual like structures and we're trying to prove certain things are equal and stuff. We'll get back to them. Symmetric is something we do use in algebra, where you take an equation, you like flip the right and left side around. Usually what they do is they start you with an equation and then later on you have to flip it. We'll see that one. That's actually a part of one of the homework problems that I want to show you today. One that you actually had in the book. So just to explain, like if you looked at it a certain way. Transitive property. When you're given like two equations and you make a new third one off of it because maybe they shared something like they shared the b's here, so you place a and c together, that kind of thing. We'll see that one. That one will actually come up in future homeworks as well, especially in geometry. We'll use that quite a bit. It's usually used kind of near one of the last lines sometimes too. Now the main ones you had in your homework. These were like majority of your homework problems that you had on Friday. You had to give me like these. Like, oh, I noticed that they're adding to both sides. They're multiplying both sides, that type of thing. And they're magically doing something. So on these particular properties, 4 through 7 here, you have to make sure that you write like addition property of equality, or multiplication property of equality, or subtraction property of equality. The reason being is that we're going to have multiple addition properties, multiple subtraction properties, and I don't want you to like get confused which one's which. That's why we call these properties of equality. We only do these for equations. Okay? These are the main ones. Now, the other two properties we did discuss on Friday and Thursday. Substitution, when you actually do like some simple math and you compute it. And division. Or distribution. Sorry, distribution, when you plug something through a parenthesis. So those are like the two extras. But those are actually field properties. Those aren't actually properties of equality. The book lists them there, but they're not. They're actually field properties. So. But these are going to be the new ones we're going to cover today. Now, the first thing I want to make sure of is Do you know how to use these? So I'm going to do a homework problem. Make sense? Well, let's do like one from your book, so you can get kind of a freebie and you can kind of see did you do it right. That type of thing. So let's take a look at your book if you have it out, or maybe your homework out. I want to take a look at like a problem like, let's go problem like number 6. Do number 6 of your homework, because it's one where you have to do your own proof. You have to prove why something works, or if it works. That type of thing. All right. So let's do some next here. So this is problem number 6. It's from your page 139. So page 139, number 6. Okay, now this is an algebraic proof. So on this problem it says like if something then something, right? It's a conditional statement. So here's what it says: if negative 4 parentheses, what's in that parentheses? X minus 3. Okay, keep going. X minus 3, then what?
Plus 5x.
Plus 5x equals 24. All right. Then x equals 12. Okay. So. All right. So this particular problem, all we have to do is show why or if that thing is equal to 12. That's the idea. You got to show some of the math. Now we're not doing like full on like every single property known to man. It's just like shortcuts. Like you know the basic stuff right there. That basic stuff. Okay, so first, when we always start a proof, I always write the word proof down, right? That's just what I'm always doing. So proof number 6, right from your book. Okay, so first line, what you always start with the given information. What did they give me? What did they give me? Yeah, the equation. You start with that. So this is the first line. Negative 4, x minus 3, plus 5x equals 24. That is your given step. That's your property, right? You have to start with that. That's what we start with. So that's what you have to do in like number 5? You have to do the same thing. Number 7, the same thing. You start with what they give you, like the equation. Whatever the first line is usually. Before the word then. This should be the last line. So like down the road, we should finish with x equals 12. That's the goal. So we know what we're going to end with. We just have to get there by doing simple properties you can use. And don't overthink it. Today it's just about going as quick as you can. Can you figure out the basic things you have to do there? So like on this first step, when we first start the problem, what's the first thing we should do? Yeah, say it.
Distribute
Yeah, you distribute the negative 4, right? You distribute through the parentheses. You're absolutely right. So on this, I'm going to actually distribute that, and I'm actually going to hand it out. Now I know I'm skipping a couple properties here, but it's good to see it. Like you want to do that type of math. So it's what? Negative 4x plus 12, right? Because when you multiply the negative 4 times negative 3, plus 5x equals 24. So so in line number 2, I distribute distribution. Make sense? Okay. Next step. Let's combine the x's. Now I know I'm not moving things around because again we're skipping properties. We're just trying to show the basic, like what were the main things we were supposed to do. So when I look at that problem, I want to add the x together. What do you get when you add the x's? You get 1x, right? So it's just x if you just want to put that. So it's just 1x, or just put an x plus 12 equals 24. Now the reason why I'm allowed to do that, it's simple substitutions. That's the main thing that we did there. That's the main property. We substituted, negative 4x plus the 5x and made 1x and single x. Make sense? Main thing. Okay? Alright, now, what's the next step that I need to do? Subtract 12. So I'm going to subtract 12 to both sides. When you do that, you get this. I subtracted 12 to both sides. And again, the major property that I just did there is the subtraction property of equality. Now, if you want, I'm totally fine with this because proofs are kind of open-ended. If you wanted to do this, I'm totally fine with this. You want to show that you're actually subtracting 12 to both sides. That is perfectly fine. You're actually showing me work that you're doing. And then the next line, if you were that person that added one more extra line, maybe you did this. So line 5, if you were just slightly different, you did this. X equals 12. Because you actually did the math and you put the substitution here. That is totally fine. Because again, we're just trying to do the main properties, and I don't mind how you modify that. It's just, are you getting the major stuff down? Do you know that you have to distribute? Do you know that you have to actually substitute by when you add the variables? Do you subtract both sides? Like, are you getting those major bullets? Those are the things I'm checking for. Make sense? Okay, don't overthink it. Today is about getting the basics down, like the major properties. Okay, questions, comments on anything. Now, obviously, proofs can be done different ways. You just need to realize that. Like, some people, when they look at this problem, they might want to subtract the 12 first, and then they'll add the variables together. That's fine. It's however you do it. As long as we're getting down to that x equals 12 in the end, it's still fine. But are you listening to like the major stuff you're doing? Like, so it doesn't have to be perfectly in order. That's I think for some people they get so stressed, like, oh my god, I didn't do it exactly that way. It doesn't matter. As long as you get the basics down, you're going to be fine. Okay, questions on number 6 at all? I'm sure you kind of two different ways. Some people kind of approach it. Okay, those are the major stuff. So obviously, the 2 extra properties we talked about Friday was substitution and distribution. That was kind of a big one. That's why I want to bring that one up, just so you can kind of know what to do. Now, obviously, I am skipping a ton of properties here, like major properties that come with field properties, but we haven't talked about them. That's why I wasn't worried about them. Okay, now, here's a question to you, because I know we're still in the review of the homework. Is there any problem that you looked at that you're like, I'm not sure how to even start that problem, I'm still confused, I didn't like it, certain one that you want to see right now? Okay, I'm going to give you some time today to work on it. I will give you some time so you can actually look at it, because I think what I have to do one. But what I want to do today for sure is talk about some of these field properties. That's what we're going to be doing the next couple of days. So I want to at least intro a couple of them today, and then we'll finish the next couple of them. That way you can have some time. I'm going to try to give you about 15 minutes today to work. So I'm going to take about 10 more minutes here, and I'm going to intro these next couple properties. So let me scroll through them again. This property sheet is online, so if you want to look at this, it's on the website. It's under today's notes, Friday's notes, Thursday's notes. I call it the study guide. It's just properties. They're in your book, by the way. These are anyway. The field properties are not. These are like extra ones that I do want you to know. It's correct mathematics. You need to know these. So, because the books tend to like just group a bunch of properties together when it shouldn't. Okay. So let's scroll down here. What we're going to be talking about right now is the field properties of real numbers. Now we're going to start this week going more in depth. What are the basic properties you need to know? Like little things. Like obviously when I did that problem, I skipped a bunch of properties. Like a bunch. Like when you distribute, there's a bunch of properties that are used for distribution. When you add variables, like adding that negative 4x and 5x, there's a bunch of properties used. They're the field properties. That's what you need to realize. So I do want to show you these to make sure that we know them. So I will, you will be assessed on these. So that you, they are a part of the parts that I do test you on. So you got to know them. And the good news is you get to use the property sheet, which I will give you one of those, where it has all the names of all the properties. So you'll get one of these in hand later this week, like Thursday this week. So then when you get to the test, you can actually use it. Right now you have your computer, so you can always have it out in front of you. Okay. Now, field properties. Let's talk about these. There is 7 of these, so you can see kind of number 1 is called closure, 2 is commutative, 3 is associative, 4 is identities. There's actually 2 identities here. You can see them. They're italicized. There's 2 inverses. There's the property of opposites, and then there's the reciprocal property. Sorry, went on to the next page. And then 6-1 is distribution. So there's actually a total of, there's technically 8 of them, because number 5 has 2 and 4 has 2. So there's technically 8 properties there, but there's 6 by name. All right, so let's talk about these. My goal today is to go through the first 3. That's it, just 3 of these. Do we know how to use them? Do we know what it's used, what it's named for? Okay. All right, first one, they call it the closure property. That's the correct title of it. I never call it closure. In fact, the name that I used, and in fact you've already used it here, instead of calling it closure, we call it substitution. Okay, so let me, so if you want, so if you're taking notes, you're writing down, closure, you can put underneath it, it's actually the substitution property. That's where it actually fits with the property of all these algebra problems. The book refers to it as the property of equality. Is actually a field property. So this is the correct title. This is the name that I'll give it. Okay, off to the side. What substitution is? It's any time you do simple arithmetic and you replace the answers. Okay, so over here, if you want to write, it's simple arithmetic. Anything that you do. So, multiplying numbers, dividing numbers, adding, subtracting. The only stipulation is, the only weird stipulation is if you're adding numbers and it makes 0, it's not substitution. Okay? So that's what you need to realize. So if you add numbers together somehow and they make 0, that is not substitution. That's a different property that's below. Because making 0 is a very special property. So not substitution when whatever the numbers are. So how do you add numbers together that would make 0? What do the numbers have to be? They have to be the same. One's negative, one's positive, right? That's the only way that you can make 0. So anytime that happens, that's actually a different property down the list. We'll look at that one tomorrow. Okay? Or when you divide numbers and it makes the number 1. Okay, so like you take a number x and you divide by y and it makes the number 1. Not substitution. Because making the number 1 is very special. That's a different property down below. It's actually one of the same properties. I just listen right here. Actually related to each other. Okay? And or if you add 0. Or you multiply by the number 1. These are not substitution. So it's a lot of zeros and ones. Like, did you create 0? Did you create the number 1 by a certain way? Those are different. But anything else, random other numbers, like the example I gave you, 12 plus 6, right? When you find the sum of two numbers, like in the middle of a math problem, and you replace that with 18, that's just substitution. You did simple math. It's not, you're not creating 0 by adding numbers. You're not dividing numbers to make 1. You're not multiplying by the number 1 or adding 0. These are like special properties. So it's anything else, any other random number you can possibly think of. So like on that problem, at one point I took took a negative 4 times a negative 3 and I wrote 12. That was substitution. And that was just simple arithmetic. Later on, taking the 24 minus 12, that was substitution. And this property right now, this one, 12 minus 12, that's a different property. That is technically not substitution, but you may have to do that bigger. So, this 12 minus 12 is actually a different property down here. Okay, do we feel comfortable with closure? A lot of people think like when you do a math problem, it's just all closure. It's all substitution, 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 substitution. It's not. There's actually some other properties you have to do. And especially like these situations. If there's other properties other than just substituting every single time. It may seem like it, but it's not. Okay, that's closure. Second one is called commutative property. Commutative is when you move things around in the middle of a problem. You can do this at any moment in the middle of an algebra problem. In fact, I actually did it on that problem there. I just didn't write it down. It was right at this step, going from line 2 to line 3. I actually did commutative somewhere in between. Because commutative is when I move like terms together. Like when I move the 5x and the 4x, like I move them side by side, that's commuting. It's grouping together and moving things around. You're supposed to do that in the middle of a problem. I just didn't write it because you weren't focused on that for your homework. It was just basic stuff. So like in this case, I can just like on an equation, I can just switch these around. Not like going right and left. I'm talking about like in the middle of a problem. So something like this. 5 plus 2x plus y minus 3 plus 4x equals 12. Just can move the x's together. I can move the whole numbers together. I can put them anywhere I want. You're commuting. You're moving things around. So like in the next line, I would write this. 5 minus the 3 plus the 2x plus the 4x plus the y equals 12. That's, I just commuted. From here to here, I commuted. Moving away terms together before I add them and subtract them. That type of thing. A lot of people do it in their head. It's an automatic. Oh, I can combine my terms here. But it's actually a property, so sometimes you got to slow down. So like later this week, we do another assignment on proofs, where we start slowing down, we start looking at all the properties, not just the basic ones like you did, but everything. Now we got to focus on, okay, when we move stuff, we have to name that properly before I move on. Before I like start substituting, because the next step, 5 minus 3, that's just substitution. That's 2. So I can replace that. That type of thing. Okay, questions on commutative? Okay, not bad. These are like the easy properties. That's why I want to start with those today. These are the ones that most people know. They just didn't realize what the name to them. Especially like this one. We got to use that one. All right, third one. Third and last one today, anyway, because we'll go on tomorrow. We'll continue on, because I don't want to overlook it. This is a lot sometimes to take on. This one is called the associative property. Okay? Associative is basically, a lot of people, and why I put these in this order, they're not like, these come in no particular order, right? I don't care that this one's number 1 and number 2. It doesn't matter. Lists can be different orders. But this one, the associative, it looks a lot like commutative. And that's some parts that some people find really challenging. They don't know which one is which. What I can tell you, if it's associative, you're just moving parenthesis bars. You're not moving the terms like this one, where I move like A and B around, or not probably move the 3 and the 4x around. That's commutative. What associative is just moving the parentheses around. It's not actually moving the numbers around. So the example I gave here was like on this problem, like if you look over here, I had the parentheses around the A and the B, and in the next line, suddenly the parentheses were around the back numbers. Okay, it's not changing like the order that you wrote anything. It's just moving the parentheses. Why you would ever do that? Why you would ever choose to multiply or choose to switch the parentheses around? It's when there's grouping things, like when they're saying, hey, find the sum of these two objects. So the objects are like 3x plus 2 plus 7, right? That's your problem. Well, can I add 3x plus 2? Can I add those together, even though they're in parentheses? No, because that one doesn't even have an x on it. So what you actually have to do is you have to actually move the parentheses. You either have to get rid of it or move it to the back, like with around the 2 and the 7. It didn't change any math. I didn't change any of the numbers. I didn't move the order of the numbers. I just moved the bars themselves. That's associative. Sometimes associative is just the simple fact of you taking away the bars. Like, oh, I already added everything together. I'm going to get rid of the parentheses bars. Okay, that's associative. And now, so this is the associative going from here to the parentheses. And then going on, it would be substituting, like taking the 2 plus 7. That's substituting stuff. Here's what I can tell you right now. Associative, that property, is a 100% guarantee. It is a 100% guarantee. Associative follows distribution. Like on that last problem that we did, problem number 6, where I had the -4 and I distributed it through the parentheses? I skipped a step there. There is a step going from line 1 to 2 where you actually have to move the parentheses bars. Because the parentheses were there. They're actually keeping the -4 out of them. So I had to actually put the associative property. So it's literally 100% guaranteed. It follows distribution. That's just what you need to know. We'll look at that one more tomorrow because we haven't got really in depth with distribution yet. We'll look at that one tomorrow. We'll start with it. Okay, questions on these three main properties here. Okay, now obviously you don't have to use these for your homework. The only one that you had was substitution. That was the only one that you were doing because there was some simple arithmetic you had to do in your problem. Okay? Alright, I'm going to give you some time today where you can work. I told you I want to give you about 15 minutes where you can just kind of work in your homework today and you can ask questions. So you can do that right now. You can move around. Page 139, that is due tomorrow. So make sure of that. Okay? Make sense? Okay, go ahead and start working. If you have questions, don't be afraid to ask. Somebody else probably has the same question as you.
Or is state volleyball next Tuesday or next Thursday? I mean?
Yeah.
Next Thursday.
The
Okay.
10th?
10.
Yeah, it's only for the first. And be like talking about
Yeah.
Yeah, it's kind of a bonus for sticking it out.
Uh huh.